So good afternoon, myself Acharya Vishwendra. Let's discuss the nucleus again. So here is a concept of the mass defect. So mass defect is that suppose there are nucleons in the free state. When they are not bounded together, they are free and independently. Practically it means that there is infinite separation between the nuclei. But when they form a nucleus, they are bounded, and when it happens, a certain energy is released. So if we analyze the two sides of this equation in terms of energy and mass, we can say that when these nuclei will be given a certain energy, then they will be free. So that certain energy is called the binding energy of the nuclei. And mass defect is suppose in a free state the mass of the nucleons counts to be m1, and in bounded state it counts to be m2. So this difference of mass is the mass defect, and it has been observed experimentally that m1 is greater than m2 or m2 is less than m1. So the difference of mass corresponds to a certain energy which has bounded the system, and that certain energy has to be provided to make them free, so which accounts for the energy mass equivalence. So we can say that the mass defect is total mass of nucleons minus the nuclear mass into this thing. So we have delta EB is equal to delta M into C square, which is the binding energy. There is a concept of binding energy per nucleon, so you divide binding energy by A, so you get binding energy per nucleon. There is one important result that 1 UC square corresponds to 931.5 mega electron volt. It is calculating things very fast, in a very fast way. So there are certain important things like rest mass energy of electron. So if you substitute the mass of electron, it comes out to be 0.511 mega electron volt. For proton mass is this, energy is this. For hydrogen atom, these are the masses and energies. For electron, for neutron, these are the corresponding states. So where P refers to proton, H hydrogen, E electron, and neutron. Now there is a concept of binding energy per nucleon. So if we draw the graph between binding energy per nucleon, it is a graph like this. So we can see from the graph that it is maxima corresponding to A is equal to 56, which corresponds to iron, and maximum value being 8.5 mega electron volt. This is maximum for this. Then you can see in the middle range, this is nearly constant, about 8 mega electron volt per nucleon, and it is lower for lighter as well as heavier nucleons. You can say it is lesser over here and over here also, which explains why there is a concept of fission and fusion. Why fission and fusion occurs? It's just to get stabilized and just to maximize binding energy per nucleon, which is in the middle range. So lighter atoms have a tendency to form heavier atoms, heavier nuclei, sorry, and heavier nuclei have a tendency to form lighter nuclei so as to have maximum binding energy per nucleon. So this is explanation for that. Then there is a concept of Q value of a reaction. Suppose there is a nuclear reaction in which A plus B gives C plus D plus Q. Then Q is the energy released in the process, which is equal to the mass defect, and which is equal to the mass of reactant minus product into C square, which is also delta M into C square. And this kinetic energy is often liberated as this Q value is often transferred to the kinetic energy of the daughter nuclei, and this is K final minus K initial, and it is equal to K final if initial kinetic energy is 0. So we can say that Q value of a reaction is mostly given to the daughter nuclei in terms of the kinetic energy. There is another important concept in terms of binding energy, that Q value is binding energy of product minus reactant. So this is how we can work out. Now there is a concept of nuclear force for which there is a concept of nuclear potential energy or potential energy due to nuclear forces. So if we held two nuclei and study the variation of the interaction between them using nuclear force, then a graph has been found experimentally like this. So you can say that there exists a neutral point at 0.8 fm and for greater than 3 fm. So there are certain points about nuclear force. The first is it is strongest force inside the nucleus. Then we have it is repulsive for distance less than 0.8 meter, attractive for 0 to 3, and it is 0 for r greater than 3 fm, and obviously at r is equal to 0.8 fm. Next is it is charge independent, that is nuclear force between neutron neutron is equal to between neutron proton and is equal to between proton proton. Next is it is a non-central force, so it's not like electrostatic force which acts along the line joining the two charges, so it's non-central. Next is it follows saturation property, because of which you can see that after 3 fm it reduces to 0, so there is no force, and after that limit there is saturation involved in this, so that is why it is called saturation for this particular force. Next on now we have radioactivity. So because of nuclear forces, the nuclei are in a dynamic way and aspiring to lose their energy. So they lose energy by emitting certain radiations, basically alpha, beta, gamma radiations, to reduce the internal pressure due to nuclear forces. So that concept is called radioactivity. So radioactivity involves emission of three things: alpha particle, beta and gamma. So if some nuclei emit alpha particle, which are helium nuclei, the mass number decreases by 4, whereas atomic number decreases by 2. So here alpha particles are emitted. Example is given, suppose that X emit alpha particle, so Z will become Z minus 2, A will reduce to A minus 4 plus 2He4 plus Q value. Example is that of 92 uranium 238, it gives thorium, helium and Q. The Q value here is 4.25 mega electron volt. Next is beta decay. It is of two types, beta plus and beta minus. Beta minus are electrons and beta plus are positrons. So during beta minus decay, atomic number increases by 1 while mass number remains the same. And the concept here is a neutron gets converted to proton plus electron plus antineutrino. And for beta minus, beta plus radiation, the reverse thing happen. Atomic number decreases by 1, mass number remains the same. And here the concept is proton decays into neutron plus positron plus neutrino, and this reaction takes place only inside the nucleus. Then we have gamma decay, in which gamma radiations are emitted, corresponds to the highest frequency radiation, as we know that. So the famous example is that of 27 cobalt 60. It emits 2 gamma ray photons and gets converted to nickel. So now there is also concept of nuclear fission and nuclear fusion. Nuclear fission has a standard example of uranium fission, and fusion has many equations out of them. This is the popular equation, and it yields the energy source at the sun, whereas nuclear fission is used in atomic bombs and in nuclear reactors as well as. So this was a brief regarding very technical things of nuclei. We covered mass defect, then found the relation, then analysis of binding energy per nucleon, which ultimately leads to radioactivity, which are three types: alpha, beta and gamma. In alpha, atomic number decreases by 2, mass number decreases by 4. In beta, there are two types, beta minus, beta plus. In beta minus, mass number remains the same, atomic number increases by 1, whereas in beta plus, atomic number decreases by 1. So of beta minus is conversion of neutron into proton, electron and antineutrino, whereas in beta plus the source is proton yields to neutron plus positron plus neutrino. And then we studied about fission and fusion. I hope it works for you. Thank you.